Since the inception of grander water revitalization, there have been two questions. How does grander water revitalization work, and can its effects be scientifically validated? The field of applied water physics focuses on researching the fundamental properties of water, especially its interactions with electric, magnetic, and electromagnetic fields, and the impact of such interactions on living organisms like bacteria. In the past 140 years, much research has been conducted on the effects of magnetic or electromagnetic treatment on water. However, the scientific community was skeptical of claims that the influence of a magnetic field on hard water affects the structure and morphology of calcium carbonate crystallization, primarily because there was no plausible explanation for the lasting effects of magnetic fields, even after exposure had ended. Therefore, the application of magnetic water treatment was controversial among professionals, not only regarding grander water revitalization. In 2016, interdisciplinary scientific collaboration between universities and research institutes in Europe's Competence Centre for Sustainable Water Technology, WETSUS, led to a breakthrough in understanding the magnetic treatment of water from the perspective of water physics. The 2016 study translates as strong gradients in weak magnetic fields induce dollop formation in tap water. The experiment. Water samples were treated with a grander water revitalizer and compared to non-treated samples. A grander water revitalization device consists of a lightly magnetized metal housing and a core of revitalized water. Therefore, in a scientific context, it is referred to as a water core magnet. What was the result of the dollop study? The study proves that the use of grander water revitalization devices reduces the formation of lime crystals. The practical benefit: lime dissolved in the water no longer crystallizes on the pipe walls. Instead, dollops, the precursor to lime crystals, form and are flushed out with the water flow. This means that undesirable bacteria and biofilms hardly find any more conditions for growth. The research group was able to prove the valid hypothesis of basic mechanisms of magnetic water treatment using a grander water core magnetic cylinder. The results of this study have been published in the peer-reviewed journal Water since 2016.